Hey everybody, this is Mr. Gurdias, and this is the lesson for compound inequalities. So if we look at our I can statement here, what we're going to be able to do by the end of this video is we will be able to solve compound inequalities by splitting them into two separate inequalities and then just solving from there. Okay, and we're also going to be able to graph our solutions. Okay, so if we take a look, this is what a compound inequality is, you guys. It's this right here. It's when you have two inequalities that are compacted into one separate one whole inequality. So I have 2 is less than x plus 5, which is less than or equal to 9. So this x plus 5 is somewhere in between 2 and 9. So what we want to do is we want to figure out what x is in between. So what I need to do is I need to separate this compound inequality into two separate inequalities. So I take this middle piece right here and I move it over, and I'm going to have this included in both sides. So this becomes just 2 is less than x plus 5, and also x plus 5 is less than or equal to 9. So now that I have these two separate inequalities, I get to solve. Okay, so we have the same problem right here, and what I'm going to do is I'm going to actually solve these, and then we're going to look at the graph. So if I have x plus 2 is less than x plus 5, I just need to subtract 5 from both sides, because my goal is just to get x by itself. So when I subtract 5 from both sides, these cancel. I'm left with x. There's my symbol. It comes straight down. 2 minus 5, that is negative 3. So I have negative 3 is less than x. Now, real quick, why don't we graph this? So I need to find my negative 3 here, which is going to be at this point. I have an open circle on negative 3. And let's see, x is going to be bigger than negative 3. So all these numbers shaded to the right are bigger than negative 3. Okay, so now let's do this in a different color here. Let's do this one in red. I have x plus 5 is less than or equal to 9. Again, I just need to solve this for x. So by doing so, I need to do the same steps by subtracting by 5 on both sides. I'm left with x is less than or equal to 4. Now let's go ahead and graph that solution. I have 4 less than or equal to, so I have a closed circle, and if it's smaller, it's shaded to the right. So these are my two separate inequalities, and they are both graphed on the same exact number line. But if we notice, I have some overlap here because x is less than or equal to 4 goes all the way infinitely to the left, so this goes on forever. All these numbers are less than 4. And then x is bigger than negative 3. That's all these numbers to the right on the blue graph. Where these intersect right here, this is a solution to my graph. So really, my final answer, my final graph should look something like this. And I'm just going to stop it here. And this is my final graph if I had to put this on the number line. So let's actually put that on the number line just to make it look a little bit better. There we go. There's my final graph because it's the intersection of those two places. This is where x is between negative 3 and 4. Okay. Now, let's look at another example then. So I need to separate this into two separate inequalities. So I have negative 5 is less than or equal to negative x minus 3. And then I also have the inequality of negative x minus 3 is less than or equal to 2. And then now I just need to solve for x. So let's go ahead while I'm over here. We'll solve for this one. So I'm going to add 3 to both sides. It's going to give me negative x is less than or equal, it's supposed to be 3, 5. Now, I just need to divide both sides by negative 1 because I can't have negative x. I want a positive x. So if I divide by a negative, negative divided by negative is positive x. But when I divide by a negative, we have to remember this rule. We have to switch the direction of our sign. And 5 divided by negative 1 is negative 5. So I have x is greater than or equal to negative 5. So now let's go ahead and let's graph that solution. So here, let's put 0 here. I'll put negative 5 here, right? 1, 2, 3, 4, 5. Yep, negative 5. X is greater than or equal to negative 5. That's going to be a closed circle, and I'm going to be shaded all the way to the right. Let's do our second inequality. Add 3 to both sides. I'm trying to get x by itself. Cancels, I get negative x. Less than or equal to, let's see here, negative 5 plus 3 is negative 2. And I need to do the same thing I did earlier, is divide both sides by negative 1. I'll get positive 2, switch my sign, because I divided by negative. So positive 2 is greater than or equal to x. So here's positive 2, greater than or equal to, I'll have an open circle and shaded to the right because x is smaller than that. And if we look, we can see where both of these numbers intersect, both these graphs intersect is this area right here. So I'm just going to regraph it just so it looks a little bit nicer right on the number line. And my solution is all these numbers in between. And the compound inequality really looks like 2 is greater than or equal to x, which is also greater than or equal to -5. And I realize I just made a mistake. This needs to be a closed circle as well. They're both greater than or equal to. Whoops. Sorry about that. Okay, and I'm done. So there's my graph in red right here. It's the intersection of my two inequalities. Okay, now just real quick, let's look at the difference between an AND graph and an OR graph. Okay, and the graph of a compound inequality with AND is the intersection of the graphs of the inequalities. That's what we did over here. We have an AND graph. We have -3 is less than x, and x is less than or equal to 4. Okay, so that's an AND graph right here. Now, if we did two separate inequalities, just real quick, if I had, let's see, 0, this would be -2. If I wanted to graph this, x is greater than -2, I have an open circle, all the numbers greater than. So then if I had the graph of x is less than or equal to 1, I'd have a closed circle shaded to the left. So if I want to do an AND graph, it's the intersection of these two graphs, which is what we just did. And so here would be my 0, -2, 1, and I would just combine both of these graphs, and that would be my final answer. Okay, that's what we've been doing. Sometimes we'll see inequalities where we have the word OR in between them, and then that is actually the union of the graphs of the inequality. So here's what I mean by that. If I have the graph x is greater than or equal to 0, well, here's 0, x is greater than or equal to, here's my graph. And then I have that graph x is less than -1. Well, let's put here 0, -1, less than -1. There's my graph. Well, if I were to combine these two, but with the word OR in between, so it's not an AND, it's not an intersection, it's going to be a little bit different. My solution is either x can be either less than -1 or x can be greater than or equal to 0. If I were to graph these, I'm still going to combine my two graphs. But if we notice, when I combine these two graphs, there is no intersection. There's this gap in between. I have two graphs going opposite directions. And then that's fine. This is my graph. This is my solution. That means that x can be any number that's less than -1. So all these numbers that go on infinitively all the way to the left, infinitely all the way to the left, or all these numbers that are bigger than 0 to the right. Okay, that's my solution. That's the OR. So x cannot be any of these numbers in between because these are not included in the solution set. So let's take a look at an OR graph real quick, and then we'll be done. So if I wanted to solve and graph this solution, I have 2m minus 1 is greater than or equal to 5, or f 5 times m is greater than -25. So let's go ahead and solve and then graph both of our solutions. So I need to solve for m. So then in order to do that, I want to get m by itself by adding 1 to both sides. I'll be left with 2m greater than or equal to 6. Now I need to get m by itself. I need to divide both sides by 2. M is greater than or equal to 3. Okay, now let's go ahead and just graph that while we're here. So I'll put 0, 1, 2, we'll make sure 3 is right here. Greater than or equal to 3 is going to look like this. Okay, now I have 5m is greater than -25. So let's go ahead and solve for m by dividing both sides by 5. And I'll be left with m is greater than -5. So let's go ahead and graph that. 1, 2, 3, 4, 5. Here's my -5. Open circle, shaded to the right. So I graphed my two separate inequalities. So I have m can be greater than or equal to 3, or m can be greater than -5. Well, if I look at my graph, if it can be either or, it's really just going to be the graph of m is greater than -5, right? Because isn't this m is greater than or equal to 3? Isn't that included in m is greater than -5? This is part of this graph. So really my actual graph really just needs to be this right here. And I'm done. This is my solution. M is greater than -5. Okay, guys, that's it. So if you have an OR, just make sure you do the two graphs separately. Sometimes they will overlap like this. Sometimes, though, they won't, and there'll be a big gap like this, and that's fine. That means your solution is all these numbers and all these numbers and nothing in between -1 and 0. If you have the and, that's going to be the intersection of the two graphs. So it would be something like this, where you have two graphs going infinitely each direction. So where they overlap is your solution. And then real quick, whenever we have a compound inequality, just make sure we separate it into two separate inequalities and then just solve for your variable on each side to create your compound solution, and then you can graph it from there. And that's it. I hope this video helped, and good luck to you guys, and I hope everybody has a great day.